The ID function in Python returns an integer that uniquely identifies the object. The ID may not directly correspond to the object's memory address. Why is the ID function useful? You finally have a tool to debug your deep and shallow copy problems. A shallow copy is a copy of a memory address instead of actual values. A deep copy, in contrast, is just a copy of the actual values. Ints, floats, strs, frozensets, tuples, and bools are immutable. They can only be changed by assigning a new value to them. They don't run into the problem of deep and shallow copies. Lists, sets, and dictionaries are mutable. They can be changed without assigning a new value to them. Here, you have the list A. The second line copies the memory address of A into B. You see as much when you get back true that their IDs are equal. If the IDs are equal, it indicates they're the same object or a shallow copy of the object. When you change the 0th element of B to 12, A is also affected because they refer to the same list object in memory. Here's a similar story. A and B hold copies of the same set, so when you use the union operator on B, A's set get changed in the exact same way. An interesting spin happens when you do the same thing, but use the union function on B instead of the union operator. When you check if A's and B's IDs are still the same after calling the union function, you find out they aren't. So the union function being called created an entirely new set for B. If you found this video helpful, please consider liking it to support the channel. If you're trying to learn code, hit that subscribe button. And if you're interested in Python's built-in methods, check out the playlist on screen now or in the link in the description. Ciao.